Crash Course on Tech for Non-Tech Founders Video 2. If you didn't watch video 1, I recommend you to do it before this one. In the first video, we tackled mobile versus web and front-end versus back-end. In the second video, we are going deeper into some basic software concepts. To dig into it, we'll use the LinkedIn app as a case study. And the first concept we are tackling is the database. Database is the brain that knows it all. But before we get down to it, let's kill a classical misconception. Are databases and storage the same thing? The answer is no. Storage is where we store things. Everything, in fact, from code files to all kinds of assets like images, videos, etc. And of course, databases. But while in storage/server we store everything including databases, in the database itself we only store organized data/information. Now, how does the database work? Think of it as a group of connected spreadsheets. The classical database structure is composed of a number of tables and they can all be connected. A classical relational data model looks somewhat like this. And in such a data model, we represent the structure of each table and the relationships between those tables. This might seem pretty vague, so let's use LinkedIn example to explain the basic concepts of relational database. As you can imagine, LinkedIn has a very complex data structure model, and we are looking at the simulation of, let's say, 1% of the complexity, but enough to understand how it works. This represents the members table, and the columns of its table are member ID, email address, date joined, the first name, the last name, and etc. The second table is the experiences. All the work experiences from members are stored in different tables. Members and experiences are connected in a one-to-many relation. This means each one member can have multiple work experiences. Now, looking at the tables, let's try to understand their relationship. We can pick Karen on the members side. Her ID is 123. When we look up her ID in the experience table, we'll find she worked for Facebook, then Google, then My Startup Inc. We can even see the dates and understand she's still working at My Startup Inc. because we have a from date and we don't have a to date. Now, let's look at members connections. The relationship is many-to-many, meaning any member can have multiple connections and any connection can as well have multiple members. So looking into the tables, we can see Karen, as the inviting member, invited John, ID 42, Mary, ID 942, and Peter with the ID 452. We can also see John and Mary accepted her invitation, while Peter is yet to accept the connection invitation. This means for Karen, Peter will show as an unaccepted invitation, while for Peter, Karen will show as a pending invitation. NoSQL, non-SQL, non-relational databases, they're all the same. And it became extremely popular in the startup scene. We'll get to know why it became so popular, but first, there's another misconception to kill. So, we know it's called non-relational, but don't follow the name literally, because it's non-relational doesn't mean you don't create relations. Actually, you can create relations in non-SQL, but in a different way. So in a relational database, you have tables. In a non-relational, you have collections of documents, also connected among each other. There are lots of differences tech-wise, which we don't need to tackle now. But from a business standpoint, the huge difference I want you to remember is relational databases tend to be faster in some use cases, but are much more rigid structures. So whenever you want to change the structure, you might break the data consistency. On the other side, non-relational are more flexible. You can't change relation every day without breaking the structure. This is why they are widely adopted by early stage startups, because in an MVP, the database structure will be changing maybe every day. So unless you are 100% sure about the database structure from day one, you should have a structure that allows you to iterate easily. The query. Querying means requesting data from database. Think of it this way. There are over 630 million users on LinkedIn, and its database looks somewhat like this, but a million times bigger. So if you want to find Waldo on LinkedIn, you don't want to look at an endless list over 630 million of users one by one You simply want to search and find them. So search is the simplest way to explain database queries. Search parameters are query criteria. I'm logged into my LinkedIn account and I want to search for people. I'm filtering by location and I pick UK and Switzerland. It gives me 29 million results. So this is the user experience to perform a very simple query. But let's see how it works from the inside. So we want people located in the UK or Switzerland, and we want to see their profile image, name, and current work. Now, the query starts with selecting what we want to see. We're saying, hey database, give me the image, name, and current job position. We still didn't say from whom. Then we select the table we want to query, in this case members. Where is the query criteria? Our criteria in this case is only location, so we are requesting the database give me the name, image, and current job position from all members that are based either in UK or Switzerland. And the last part of this very simple query is the pagination. We don't want to look at all the 29 million in one single page, it would even kill our browser. So we are asking for 20 at a time. Offset stands for page number. In an UI analogy, we're asking for the page 1 with 20 results per page. Now that was easy, right? Of course, this was the simplest example we could use. Just to illustrate, if we just add one more criterion like first connection, we'll need to make an inner join, still a very simple one, but not as simple as first example. Public and private. Public and private is an easy topic because the names are self-explanatory. Public stands for all public information/pages that anyone can access. In theory, you can access all public pages in the world. Private is a page that only logged users can access. Authentication. In a nutshell, authenticated users are logged users. So once you're logged, you're authenticated. And as an authenticated user, you have access to private parts of the app, not necessarily to all private parts. And therefore comes the concept authorization. So even after authenticated, you don't have access to all information. The system is always looking at the user's activity, and every time a user asks to access a page, some information or perform an action, the system checks their access rules, and it might grant or revoke authorization to access. Let's go back to the LinkedIn example. I've logged in again. I see I have 24 unread messages since yesterday. This message has a specific URL. Now let's pick this URL and share it with my colleague Rui. Let's see what happens. Now we're looking at Rui logged in, and when he picks up the URL and tries it, he doesn't have access to it. So what happened was, he tried to access a page through a URL, the system was supervising his access, and first it checked his authentication. Yes, this is Rui. Then it checked the authorization to access this message, and it didn't have access because only me and the other person have access. Now the API, our last concept. Remember the distinction between backend and frontend from video 1? So on one side you have the backend, and on the other side the frontend. The API is the interface throughout which the backend exposes its data to the exterior. The API handles authentication, authorization, queries, and most beautiful thing about the API is the common language. So whatever is the language in the frontend and in the backend, they speak a common language throughout the API. That's why APIs are very important, because you can expose your backend to any frontend as well as to other backends. In the LinkedIn examples, this means LinkedIn has only one backend, but both of the web app, the mobile iOS and Android are frontends in different languages, but they are all consuming the same backend throughout the API. So now you feel like you have the power to start a geek conversation, which means we've accomplished our goal. For more content for founders, go to www.altar.io/blog. Thank you.